Hi everyone, myself is Praveena. I'm the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the topic of eigenvalues and that related problems. For the complex numbers, eigenvalues for finding eigenvalues for the complex matrices and real matrices. Okay, already we discussed in the last classes for the introduction of the eigenvalues and eigenvectors. What about the formula for the eigenvalues? Okay, that is that A minus lambda I is equal to 0. For that, we have to find eigenvalues. Okay, here what about the first question? Find the eigenvalues of A is equal to 3i, 2 plus I, minus 2 plus I, minus I. Is it a complex matrix or real matrix? This is complex matrix. Okay, for the complex matrix also we have to find eigenvalues. Okay, before going to find the eigenvalues, first I have to prove is it a Hermitian matrix or skew Hermitian. Okay, for that here, what about skew Hermitian matrix? Mm, Skew Hermitian matrix formula, that is A bar is equal to minus A transpose. Okay, before finding the eigenvalues, first I have to verify is it Hermitian or skew Hermitian. Okay, for that formula A bar is equal to minus A transpose. For that, what about the given matrix? That is A is equal to 3i 2 plus I minus 2 plus I minus I. For that, what about the conjugate of the A bar means what? That is the conjugate of the given matrix. That is A bar is equal to here minus 3i, 2 minus I, minus 2 minus I and I. That means complex number conjugate plus we'll write it as minus there. And there also write it as in place of plus as minus. And there minus I, I'll write it as there plus I. This is the conjugate of A bar. Okay, for that, what about A transpose? A transpose is equal to, that is 3i minus 2 plus I, 2 plus I and minus I. Okay, once observe, for that A matrix this is A transpose and for that A matrix this is A bar. Therefore, the two are equal. A bar is equal to A transpose. When the two are equal, there minus is missing. For that, that is A bar is equal to minus A transpose. If the two are equal, that the given matrix is a skew Hermitian matrix. That matrix is a skew Hermitian matrix. And here, now after verifying that the skew Hermitian, now we have to find eigenvalues. Okay, what about the formula for the eigenvalues here? That is, okay, for that, det A minus lambda I is equal to 0. Okay, for that, for finding eigenvalues, first we have to write it as the characteristic equation of A. That is det A minus lambda I is equal to 0. What about det A minus lambda I? That is A is 3i, 2 plus I, minus 2 plus I and minus I, minus lambda into 1001. It is equal to 0. For that here write it as just multiply with the lambda and subtracting with that identity matrix. That is here 3i minus lambda 2 plus I minus lambda into 0 0. Next minus 2 plus I minus lambda, that is minus 2 plus I, and next minus I minus lambda, that is minus I minus lambda is equal to 0. This is 3i minus lambda 2 plus I minus 2 plus I minus lambda is equal to 0. This is the characteristic equation of the given matrix. Okay, for that find determinant. Okay, for that find a determinant. From the determinant directly we get the equation form lambda square minus 2i lambda plus 8 is equal to 0. For the 2 by 2 matrix, how we are finding the determinant value? That is, take the cross multiplication of these two. After the simplification of that, directly here we get lambda square minus 2i lambda plus 8 is equal to 0. Okay, after simplifying that directly, what are the roots for that? Lambda is equal to 4i minus 2i are the eigenvalues of A. Okay, na? Already we discussed how we are finding the determinant for the 2 by 2 matrix in the previous classes. Okay, na? After getting that equation, just find out the roots for that. For that, we get directly what about the values of that? 4i comma minus 2i are the eigenvalues of A. This is the first question for the complex matrix. Similarly, I will continue with the second question, that is, find the eigenvalues of A is equal to. A is equal to what? Here this is also 2 by 2 matrix, that is 1 by 2 I root 3 by 2 root 3 by 2 1 by 2 I. Okay, now for that, okay, first before going through that, in that question what they are asking, show that the matrix as unitary also. Unitary, show that the matrix as unitary. For that, first I have to prove that the matrix is unitary. For that, what about the condition for the unitary? A into A bar whole transpose is equal to I. A into A bar whole transpose is equal to A. I. For that, here what about A bar? Okay, for the given matrix, we have to take the conjugate of that. That is minus 1 by 2 into I. 1 by 2 I conjugate is minus 1 by 2 into I, and root 3 by is the real number, and this root 3 by 2 also real number, and 1 by 2 I, that is minus 1 by 2 into I, that is A bar. And what about the transpose of that? That is minus 1 by 2 into I, root 3 by 2, root 3 by 2, and minus 1 by 2 into I. Okay, this is A bar whole transpose. Okay, just multiply these two, A bar into A bar whole transpose. For that, we can see that just multiply by that 2, we get directly this is 1 0 0 1. Already we discussed in the last classes, multiplication of the two matrices. Okay, here we have to multiply A into A bar whole transpose. What about A there? 1 by 2 into I, root 3 by 2, root 3 by 2, and 1 by 2 into I. Okay, this is multiplying with what? Minus 1 by 2 into I, the root 3 by 2, root 3 by 2, and minus 1 by 2 into I. Just multiply the 2. For that, we get directly. Okay, for that we directly once observe how we are multiplying that, already we discussed. Okay, that is first row with the first column in the second matrix, and similarly first row with the second column in the second matrix. Multiply the two. Here 1 by 2 into minus 1 by 2 I plus root 3 by into root 3 by 2. Okay, for that simplifying we get directly, that is 1. And after that again for the same row with the second column, that is multiplying with the 2, directly we get a 0. And similarly second row with the first column, multiply with the 2, directly we get 0. And these are multiplying with that is directly equal to 1. Okay, therefore, okay, after A into A bar whole transpose multiplying, we get directly one identity matrix, that is 1 0 0 1. Therefore, the condition is satisfied. Therefore, from the definition of the unitary, A into A bar transpose is equal to what? I. Therefore, the given matrix is unitary matrix. Therefore, the given matrix is unitary matrix. Okay, now for the given matrix, now we have to find eigenvalues. Okay, for that, first write it as characteristic equation form. What about the characteristic equation there? That A minus lambda I is equal to 0. That A minus lambda I is equal to 0. For that, write it as A matrix and multiplying with lambda into identity matrix. After that, we get this is the matrix for that A minus lambda I. Okay, now for that find eigen. For that, okay, determinant is 1 by 2 into I minus lambda into 1 by 2 into I minus lambda minus root 3 by 2 into root 3 by 2. For that we get directly two values of the lambda. One is root 3 by 2 plus I into 1 by 2, and the another one is minus root 3 by 2 plus 1 by 2 into I. These are the eigenvalues for the given matrix A for the complex. Okay, that are A is equal to, first one is positive value root 3 by 2 plus I into 1 by 2, and the second one minus root 3 by 2 plus 1 by 2 into I. Okay, these are the eigenvalues of the given matrix A. Okay, similarly, next question. Okay, now we discussed with two questions for the complex matrix eigenvalues. Now, similarly, I'll discuss with the another one. Okay, this is a different question. What they're asking, find the eigenvalues of 3a cube plus 5a square minus 6a plus 2i, where a is equal to 1, 2 minus 3, 0, 3, 2, 0, 0 minus 2. 1, 2 minus 3, 0, 3, 2, 0, 0 minus 2. Once observe the what about the given matrix here. The given matrix is 3 by 3. For that matrix, we have to find eigenvalues of one polynomial form. What about the polynomial form of that? That is 3a cube plus 5a squared minus 6a plus 2i. Okay, for that first we have to find for the given matrix, square matrix, eigenvalues. Therefore, here the characteristic equation is that a minus lambda I is equal to 0. Okay, for that, okay, from the characteristic equation here, that is 1 minus lambda 2 minus 3 0, 3 minus lambda 2 0 0 minus 2 minus lambda is equal to 0. From the determinant of the 3 by 3 matrix, we get directly what about the eigenvalues of that? That is 1 minus lambda 3 minus lambda 2 plus lambda is equal to 0. Therefore, lambda is equal to what? 1, 3 minus 2. Or else, if you know one property of that, this is once observe the given matrix of A, is it upper triangular or lower triangular? If whatever it is, if it is upper or lower, okay, for that case, okay, we have to take the diagonal elements of the eigenvalues. Okay, if you know that property, we have to write it as directly. What about the eigenvalues of that? 1, 3 minus 2. These are the diagonal elements of the given matrix. Okay, if you're not remembering that property, from that case directly we have to find, okay, from the formula of det A minus lambda I is equal to 0. After the simplifying also we get the same values, that is 1, 3 minus 2. Once observe from the formula also we get the diagonal elements. Or else if upper triangular or lower triangular matrix, for the diagonal elements only the eigenvalues of the given matrix. Okay, that's the, okay, now we are getting the values of eigenvalues of A. Okay, but what they are asking in the question, they are asking polynomial eigenvalues. For that here I'm observing, once observe, okay, for that here, now we get for the 3 by 3 matrix, we get 3 by 3 matrix 3 eigenvalues. What about the first one? 1, 3 minus 2. Okay, for that case, for one of the property, if a eigenvalues of lambda 1, lambda 2, lambda 3, for that polynomial eigenvalues are 3 into lambda 1 cube plus lambda 1 square minus 6 into lambda 1 plus 2 into I. Okay, na? Once observe from one of the property, if lambda 1, lambda 2, lambda 3 are eigenvalues of A, then okay, polynomial eigenvalues of lambda 1 cube plus, okay, similarly, okay, A lambda naught square plus B lambda naught square plus C into I are the eigenvalues of A. Okay, for this is the one of the property for that. If A eigenvalues of lambda 1, lambda 2, lambda 3, for the given polynomial eigenvalues are, just substitute the given polynomial first lambda 1 value, and after that substitute lambda 2, and after that substitute lambda 3. These three are the eigenvalues of the given polynomial. Here, what is the given polynomial? Once observe, the given polynomial is Okay, given polynomial is 3a cube, 3a cube plus 5a square minus 6a plus 2i. 3a cube plus 5a square minus 6a plus 2i. For that, further the given matrix A eigenvalues are once observed, that is 1, 3, 1, 3 minus 2 are the eigenvalues of the matrix A. Okay, now we have to substitute each eigenvalue in the polynomial. That is, write it as first f of 1. Let us take the given polynomial as f of 1. That means first eigenvalue. That is 3 into, substitute in the given polynomial 1 cube plus 5 into 1 square minus 6 into 1 plus 2 into I means there 1. Okay, that is 3 plus 5 minus 8 minus 6 plus 2. That is 4. Therefore, the first eigenvalue of the polynomial, that is 4. Similarly, what about the second eigenvalue, that is f of 3? Again, substitute in the polynomial, that is 3 into 3 cube plus 5 into 3 square minus 6 into 3 plus 2 into 1. For that, okay, again simplify that, that is 3 into 9, 27 plus 5 into 9 minus 6 into 3 plus 2 plus 2. Okay, after simplifying that, directly we get the eigenvalue as 110. Eigenvalue as 110. Similarly, one more. Okay, what about the another eigenvalue? That is f of minus 2. F of minus 2 is equal to, that is 3 into minus 2 cube plus 5 into minus 2 square minus 6 into minus 2 plus 2 into 1. Okay, I'm substituting the last eigenvalue in the given polynomial. For the 3 into minus 8 plus 5 into 4 plus 12 plus 2. From that, minus 24 plus 20 minus 24 plus 20 plus 12 plus 2. Okay, after simplifying that, directly we get whatever the value of that, that is equal to 10. Therefore, if lambda 1, lambda 2 and lambda 3 are the eigenvalues of the given vector, given matrix A, for that polynomial eigenvalues are just substitute after getting the A eigenvalues. Okay, each and every eigenvalue substitute in the given polynomial. From that we get directly for the polynomial eigenvalues. Here the first one has 4 and second one has the 110 and the third one has the 10. This is the answer for the third question. This is the another one for finding eigenvalues. Okay, next, similarly, next one. Okay, this is different question. Find the eigenvalues and eigenvector of the matrix A, and it's find its inverse. Inverse, where what about A there? A is equal to 1, 3, 4, 0, 2, 5, 0, 0, 3. Okay, now here I'm asking what they're asking, eigenvalues and that corresponding eigenvectors also. Okay, for that given matrix A, this is 3 by 3 matrix. Once observe, is it upper triangular or lower triangular? This is upper triangular matrix. For that upper triangular, what we discussed, for that corresponding diagonal elements only the eigenvalues of the given matrix, or else that means directly from the property, whatever the eigenvalues 1, 2, 3, or else from the general concept of finding eigenvalues means from the characteristic equation, that is that A minus lambda I is equal to 0, that is 1 minus lambda 3, 4, 0, 2 minus lambda 5, 0, 0, 3 minus lambda. From that solve the determinant of the 3 by 3 matrix. From that, okay, how we are finding the determinant value? 1 minus lambda, neglecting that corresponding row and the column, and take the cross multiplication of that, that is 2 minus lambda into 3 minus lambda. That means how we are writing 1 minus lambda into 2 minus lambda into 3 minus lambda, and minus 3 into neglecting that corresponding column and row, and 0 into 3 minus lambda 0 minus 5 into 0 0 plus 4 into neglecting that corresponding column and row, that is 0 minus 0 is equal to 0. That means simply we get 1 minus lambda, 2 minus lambda and 3 minus lambda is equal to 0. From that, what are the eigenvalues directly equating with 0? That is, lambda is equal to 1 and lambda is equal to 2 and lambda is equal to 3. These are the eigenvalues of the given matrix. Or else, what about the one more name for the eigenvalues? Either latent roots or characteristic roots. Okay, therefore, eigenvalues is equal to one more name for that, characteristic roots, or sometimes they are given latent roots. Latent roots. For that, this is equal to what? There are 1, 2, 3. Okay, therefore, these are the eigenvalues of the given matrix. Okay, here 3 are the eigenvalues 1, 2, 3. Is it distinct or similar eigenvalues? Distinct eigenvalues. For that, we have to find corresponding eigenvectors. How we are finding eigenvectors? Here, characteristic vector for the first case. This is the first case for lambda is equal to 1. For that case, okay, what about the formula for that? A minus lambda I into x is equal to 0. That means what about A there? A is 134, 134, 0 to 5 and 0, 0, 3. Okay, minus lambda into 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, but what about the lambda value? That is 1. Subtracting with that 1 minus of 1, that is 0. And next 3 minus 0, 3. Next 4 minus 0, 4. Next 0 minus 0, 0. Next 2 minus 1, this is 1. And next 5 minus 0, 5. And similarly 0 minus 0 minus 0, 0, 0 minus 0, 0 and 3 minus 1, 2. Okay, here what about x? X is, okay, unknown variables of the given matrix. That is, for the 3 by 3 matrix, I am taking x1, x2, x3 column matrix. Okay, unknowns are here 3. That is equal to 0, 0, 0. It is upper triangular. Further, directly write it as the equation from that, or else, why? Because here completely all elements are maximum zeros. Easily we can solve the equations. Here all are not equal to 0. For that case, first we have to reduce the matrix as echelon form. Echelon form. From that easily we can get the unknown values of x1, x2, x3. But directly here this is upper triangular, so that easily we can get the answers. Okay, for that write it as equation form 3x2 plus 4x3 is equal to 0. And the next one, x2 plus 5x3 is 0. And 2x3 is equal to 0. There x2 is equal to 0 and x3 is equal to 0. Bishop 3x2 plus 4x3 is equal to 0 and x2 plus 5x3 is equal to 0 and 2x3 is equal to 0. Solve that equations there. x2 is 0 and x3 is 0. And what about x1 value? We don't know that x1 value. For that case, we have to assume x1 as alpha. x1 is equal to alpha. Therefore, what about x there? That is alpha 0, 0. From the take alpha common, this is 1, 0, 0. Therefore, what about the first first eigenvector? That is 1, 0, 0. 1, 0, 0. Similarly, for the second eigenvalue, that is 2. Okay, that is 2. For that case, again write it as a minus lambda I into x is equal to 0 form and substitute there. And from that, minus 1, 3, 4, 0, 0, 5, 0, 0, 1. x1, x2, x3, 0, 0, 0. For that, minus 1, x1 plus 3x2 plus 4x3 is equal to 0. From that, x3 is 0. And after the equation, here minus x1 plus 3x2 0. x1 is equal to 3x2. Okay, from that here we get directly x3 0 and we don't know x1 and x2. For that case, we have to assume one value as the arbitrary constant. That is x2 is equal to k. Okay, from that, after assuming x2 as arbitrary, we are substituting in the above. From that we get directly x1 is equal to 3k. X1 is equal to 3k. Therefore, what about the eigenvector if lambda is equal to 2? That is 3k, k 0. Take k common. That is 3, 1, 0. Is the eigenvector of the corresponding value of 2. Lambda is equal to 2. Similarly, next one, the last case, characteristic vector for the lambda is equal to 3. For that here, okay, again same concept apply there, and after subtracting with the 3 there, minus 2, 3, 4, 0, minus 1, 5, 0, 0, 0, x1, x2, x3, 0, 0, 0. Again write it as the equation form and solve that equations directly. We get the unknown values of x1, x2, x3. From that, first write it as the equation form, minus 2x1 plus 3x2 plus 4x3 is equal to 0. In the second equation, minus x2 plus 5x3 is equal to 0. After solving this directly, we don't know exactly any value of either x1 or x2 or x3. For that case, we have to assume one as arbitrary constant x3. Substitute in the above equation. From that, we get x2 is equal to 5k. Here we know that x3 and x2 and substitute these two in the above equation. From that, what about x1? 19 by 2 into k. Therefore, what about the corresponding eigenvector? Write it as x1 has 19 by 2 into k and x2 has 5 and x3 is equal to k. x3 is equal to k. From that, x2 is equal to k. From that, I'll take it as fractional value outside. From that, 19, 10 and 2. Therefore, if lambda is equal to 3 for that case, what about that corresponding eigenvector? 19, 10, 2. Okay. Therefore, for the 3 eigenvalues, we get directly 3 corresponding eigenvectors. Okay. This is the concept. And for that, okay, here, what about the next one? So that for the given question, what they're asking, find its inverse also. Find its inverse. For that, find its inverse means already we know that A eigenvalues are 1, 2, 3. For that, A inverse eigenvalues means that reciprocal of that, that is 1 by 1, 1 by 2 and 1 by 3 from one of the property. Therefore, if you know the eigenvalues of A, from that easily we can get A inverse eigenvalues. That is 1, 1 by 2 and 1 by 3. Okay, this is the concept for finding eigenvalues and the corresponding eigenvectors. Okay, thank you. Thank you for all.
Like, share, and subscribe. Hit the bell icon for more updates.